Welcome to Brain Vision.
For the first part of this problem, we are asked, what is the value of our test statistic here? So the statistic itself is going to be a Z statistic, or the standard normal score. The way that we find this is by taking the sample proportion for group 1 minus the sample proportion for group 2 divided by the square root of the pooled proportion, p bar, times 1 minus the pooled proportion, times 1 over sample size 1 plus 1 over sample size 2. So the things that we'll need to calculate here, let's see. We have sample size or sample proportion for group 1, p hat 1, is going to be 304 successes divided by 304 successes plus 216 failures. So sample proportion 1 is 0.5846. P hat 2 is going to be equal to, let's see here, 149 successes out of 149 successes plus 80 failures in total. So we have sample proportion 2 is 0.6507 roughly. And then the pooled proportion is the total number of successes between the two groups. So that's 304 plus 149 divided by the total number of trials overall. So that's 304 plus 216 plus 149 plus 80. So we can see that the pooled proportion is equal to 0.6048. Which then means that we have everything that we need for calculating out our Z-score, though actually I'll calculate out N1 and N2 explicitly just to make those easy to reference. So N1 is 520 and N2 is 229. So we have that our Z-score then is going to be equal to 0.5846 minus 0.6507 divided by the square root of 0.6048 times 1 minus 0.6048 times 1 over sample size 1, so that's 1 over 520, plus 1 over sample size 2, so that would be 1 over 229. So we get that our Z-score here is negative 1.705 roughly. Then we're asked for the p-value. So the p-value is going to be the probability, or the proportion of observations, alternatively, or in this case, really, it's probability, of observing a Z-score less than or equal to our value here of negative 1.705. Now, of course, you can use a table of values for finding that, or a graphing calculator. I'm just going to use my software here. So for that, I put in CDF, normal distribution, negative 1.705, so this will give me the proportion of the normal distribution to the left of negative 1.705. So we get a result of roughly 0.044. Let's see here. It does not seem as though you were given a level of significance. So without being given a level of significance, the sort of typical rule of thumb value that we use is alpha equals 0.05. Though I'm just going to point that out that is an assumption that I'm making. If there is more information that you have, then go with that. But this is sort of the typical value that we assume if it's not given to us explicitly. So since we have that our p-value is less than that typical value of alpha equals 0.05, that means that our decision would be that we reject the null hypothesis. We reject the null hypothesis. So that would mean that, oh, pardon me, I just realized. Excuse me, no, at the top of the page, it says that alpha is equal to 0.001. Excuse me, no, so our p-value is greater than alpha. And so the appropriate conclusion would be that we fail to reject the null hypothesis. I write FTR for short, but that's fail to reject the null hypothesis. And so the conclusion, out of the listed options, we would want to choose option A, We were told that the claim, in this case, was the alternate hypothesis, so there is sufficient evidence to reject the claim that the first population proportion is less than the second population proportion.